Hi there, my name is Jeroen Boeye and I'm a machine learning engineer at Faktion. In this course, I'll be teaching you how to reduce dimensionality in your datasets. Before we get going, it's important to clarify some concepts. When I mention dimensionality, I mean the number of columns you have in your dataset, assuming that you're working on a tidy dataset, such as the Pokemon dataset shown here. Working with a tidy dataset makes your life as a data scientist much easier. To do so, just make sure every column resembles a variable, or in other words, feature, such as the properties of Pokemon like attack and defense in this example. Similarly, each row holds an observation for each variable. The first row gives us all the properties of one specific Pokemon. You end up with a value in each cell of our dataset. You can learn the number of rows and columns in a pandas data frame using the shape attribute. For our small Pokemon dataset, shape will return a tuple telling us there are 5 rows and 7 columns. Throughout this course, we'll be using pandas a lot and will always pre-import it for you as PD. When you have many columns in your dataset, say more than 10, the data is considered high dimensional. And if you're new to that dataset, it could be hard to find the most important patterns because of the complexity that comes with high dimensionality. To overcome this, we can reduce the number of columns using dimensionality reduction techniques. However, these techniques can also be useful for relatively low dimensional datasets, such as this one. In the dataset shown here, you'll notice that all Pokemon come from the same generation. If we're interested in how Pokemon are different, this feature would not be very useful, since it has no variance. We could reduce dimensionality by simply dropping that column. To get a quick overview of which columns contain little variance, we can use the pandas data frame describe method. By default, describe gives us a number of summary statistics for each numeric column. You'll see that for our small dataset, the standard deviation of the generation column is 0, and that the maximum and minimum values are the same. By default, describe ignores the non-numeric columns in the dataset. We can tell describe to do the opposite by passing number to the exclude argument. We'll then get summary statistics adapted to the non-numeric data. We can see that in the 5 observations there are only 2 unique types of Pokemon. The top occurring type is grass, since it's in the type column 3 times. Getting comfortable with the shape of your dataset and the properties of the features within is a crucial step you should take before you make the decision to reduce dimensionality. Another important exploration step is to visualize your data, and we'll get to that in the next lesson. But first, we'll practice. It's your turn to explore a larger sample